Here's notes 5.8 for honors algebra 2. One objective today, be able to list and find all possible rational zeros, also known as x-intercept, rational x-intercepts, using the rational zero theorem. So basically this theorem, what it's going to do is going to help us find out how to find the zeros of polynomials. So this is the rational zero theorem. Basically what it's saying is you take all the factors, when you have a polynomial that looks kind of normal, when you have a polynomial, you factor the constant term, factor the leading coefficient, and then you put the factors of the constant term over the factors of the leading coefficient. And what that's going to create is a list of a whole bunch of numbers, and inside of that list you will have your actual rational zeros, if there are any. So basically it's doing guessing and checking, but it's going to give you a smaller list of numbers to try for guessing and checking. All right, so let's go ahead and try this one. Now this is a very simple one. These are the steps over here. So first factor the front and the back, make your list is the second step, and then test your list. So factor, make a list, test your list. This is a pretty straightforward one right here. We actually already know how to factor this one, but I wanted to kind of show you this anyways. But if you were to factor this, just by knowing what you already know, that'd be x and x, it'd be 7 times 2. So we know that if this was equal to 0, we know our answers are x equals -7 and x equals -2. It's a very easy one. You could have done it, but the thing is, since this is a new concept, I do want to work it on something that we actually know how to do already. So we know the answers are -7 and 2. But the question is, how would we use what this new theorem is to do this problem? So what we're going to do is factor the front. Now the front, there's a 1 there. The factors of 1 is 1, because 1 times 1 is the only way to get a 1, so you get a 1. But you also have a -1, because -1 times -1. So we're going to say there's a +1 and there's a -1. So there's your list of the leading coefficient. 14, so 14 is 1 times 14, 2 times 7, and that's it. You also have -1 times -14 and -2 times -7. So you have a +1 and a -1, +2 and a -2, +7, -7, +14, -14. So what I do allow my classes to do, since we have all positive and negatives all the time, you can put the plus or minus outside of your list and then just list your numbers. So 1, I'm going to put them in order, 2, 7, and 14. So we actually have a list of not 4 numbers, because these are the positives, but you also have the negatives of these numbers too as part of your list. So now what we're going to do is we're going to take this list of 8 numbers, because there's the positives and the negatives, and then put it over this list of 2 numbers, which is basically a +1 and a -1. Now if you think about this, when you put the positives over the positives, you get a positive. When you put the negatives over the negatives, you get a positive. When you put the negatives over the positives, you get a negative. So you're going to get pluses and minuses basically every single time. So we're just going to keep these plus minuses outside. Let's go to make our list. So here's a list of possible answers. So plus and minus, that way we don't have to worry about putting plus and minuses all the time. So what we're going to do is we're going to take the 1 and put it over this factor. We're going to take each one of these factors and put over this factor. Now normally, sometimes there'll be 2 factors here. In that case, you'll have a longer list, but the fact is right now we have 4 numbers and we're putting them all over 1. So we're going to put a 1 over 1. Whoops, that's not a 1. That's a 1. So 1 over 1, a 2 over a 1, then we're going to do the 7 and put it over the 1, then we're going to do the 14 and put it over the 1. And that's it. We don't have anything else to put over it. So we put every single number here and put it over every single number here, which happen to be just 1 number. So let's go ahead and simplify our list. 1 divided by 1 is 1, 2 divided by 1 is 2, 7, and 14. So that's our list of possibilities. So +1, -1, +2, -2, +7, -7, +14, -14. Now it just so happens that this list matches this list right here, and it's only because we divided this list by 1. When you divide something by 1, you get the exact same thing back out. So if you were to do synthetic substitution or division, whatever you want to call it, you could actually find which ones are your zeros. Now we already know our zeros. Our zeros are -7 and -2, which is actually part of our list because we have a -7 right here and a -2 right here. So the ones won't work. And just to kind of show you this, so let's test out a 1. So there's a 1, let's pretend like we didn't know what the answers already were. So there's a 1, a 9, and a 14. So bring down your 1. 1 times 1 is a 1. 9 plus 1 is a 10, 10, and 24. Now, even though 1 did not work, it actually still gave us some information because this is synthetic substitution. So I know when I plug in an x value of a 1 into this polynomial, 1x squared plus 9x plus 14, I get out at 24. So it wasn't completely useless. We actually got a point out of it. I plug in a 1, I get out at 24. So it wasn't a 0, it wasn't an x-intercept, but keep in mind, we're eventually going to be graphing this thing, so don't just throw this information away. We know that there's a point at 1, 24, so you can plot that point when we start graphing. So even though 1 and -1 won't work, and we already know they won't because we know the answer, but then we keep trying and trying and trying, guessing and checking, and then eventually you'll come to -2, and then -2 will work. So you're going to do -2, and then do this, 1, 9, and 14. Bring down your 1, -2, 7, -14, and you get a 0. So we know one of our factors is x plus 2, and then the answer is x plus a 7, and that's it. That's what we figured out at the very beginning, actually. Well, I said it equal to 0. Should have been equal to f of x. But if you were going to solve it, f of x would equal 0. But right now we're just factoring. So f of x. Okay. So that's basically what this theorem does. It gives us a list. It narrows it down to, instead of infinity, I mean, it was eight possibilities, but it's still less than infinity. And then you just start plugging in and checking, guess and check. That's basically what this is. All right, so let's try this one. So another quadratic, starting kind of simple, so I'll go through this one kind of faster. Let's see here. Factors of 2 are 1 and 2. So I got a positive and negative, list of 1, 2. Factors of 7 are just 7 and 1, so 1 and 7. So factored that all out, that's our list. So let's make our whole list now. Positive and negative. So first, I'm going to take the 1, put it over this 1. So I'm going to get a 1 over 1. Then I'm going to take this 7 and put it over the 1 also, and I'll get a 7 over 1. All right, now I did the 1 and the 7 over the 1. I also have to do the 1 and the 7 over the 2. So I'm going to take the 1 over 2 and 7 over 2. And that's it. I don't have any other numbers to put over here. So that's our entire list. Whoops, that's leftovers from my other class. Go away. All right. So now we just start guessing and checking. So plus minus, that's 1, 7, 1/2 is just 1/2, and 7/2. All right, and just, yeah, so let's start it up. So we got 1. Let's see here, 2x squared plus 5. Whoops. 2, a 5, and a -7. Bring out your 2. 2, that's a 2, that's a 7, that's a 7, and a 0. Yay, we got the first one to work. So since the 1 worked, I know that x minus 1 is one factor. Bring down the degree by 1, so you're going to go to 2x plus a 7, and that's it. F of x equals that thing. And is there a solve list? Then find the 0. So we're going to find the 0 still. So f of x will turn into 0 equals x minus 1, 2x plus 7. Now you just solve. So you're going to get x equals a positive 1 and x equals a -7 over 2. And if you notice, both of those are in our list. We have a positive 1 in our list right here, and we have a -7/2 right here, because remember, it's always a plus and a minus, so this is our -7/2. So both of those numbers were in our list, which is what's to be expected because we just used the theorem. And that's how you use the theorem. So from here on in, it's basically going to be harder problems, and then a word problem at the end. So let's try this one out. This one, factors here is a plus and a -1. Factors here are 1 and 12, 2 and 6, 3 and 4, and a 4 and a 3. But remember, you're not supposed to have repeats, so 4 and 3 doesn't count. So plus, minus, let's put them in order. 1, 2, 3, 4, 6, and 12. All right, now we're going to make our list. plus and a minus. Now it does help here if you can kind of think ahead. We're going to take this entire list of 1, 3, 2, 3, 4, 6, and 12 and put it over 1. So anything divided by 1 is the exact same thing again. So basically your list will be this stuff right here. So 1, 2, 3, 4, 6, and 12. All right, so now let's just start from the beginning, guess and check, and see which one works. So push pause or something and start trying them out. Okay, and then I'll put the actual answer. I'm going to start with the one that actually works. That way I can save some time. But go ahead and try it out. So hopefully you've pushed pause and tried a couple. So I think 1 doesn't work. If you plugged a 1 in, you would have got, what did I get when I did mine? Negative 20. So you tried a 1, got a negative 20, and then you should have tried a negative 1, and then negative 1 actually works out. So let's go ahead and do the one that actually works. So 1 didn't work. So let's try negative 1. So 1, 2, negative 11, and negative 12. So 1, negative 1, 1, negative 1, negative 12, 12, and a 0. So it says find all rational zeros, so here we go. So x plus 1, because you got to switch the sign. So that was an answer, so we're getting x plus 1. Then you write your polynomial with starting with 1 degree less than what was here. So the degree here was cubed, so we're going to start with a squared. So it's going to be 1x squared plus x minus 2 equals 0, because we're trying to find the zeros. At this point, you can do the zero product property. Equals 0, x squared plus x minus 2 equals 0. This is x equals negative 1. Is that factor? Yes. X, it's a 2 and a 1, negative 1, positive 2 equals 0. So x equals negative 2, x equals positive 1. Wait, that doesn't make sense. Hold on. Did I factor too fast? Negative 2, 1. Let me check something. Aha! That's not a 2, that's a 12. Silly Mr. Aguirre. That's a 12. That means this is a 4 and a negative 3. Yeah, that makes more sense. And this is a negative 4, positive 3. And there you go. Yeah, I pulled a little mistake that you guys make all the time. My numbers transformed into other numbers. But I caught my mistake, so it's okay. All right, so that's how you do it. Because this, now if you think about it, we actually had another way we could have factored this. That other way that we could have factored this is by using factor by grouping. But if you try to do this by factor by grouping, it actually does not work out. So that's not always a good way to do this. All right, so let's try this one. List all the possible zeros and find all the zeros. And I gave you 2 of the zeros, and they're actually fractions. That's why I gave them to you. Otherwise, I'm pretty sure you guys would have been guessing for a while, which isn't a bad thing. But 10, factors of 10 are 1, 10, 2, and 5. So plus minus 1, 2, 5, and 10. Okay, this is going to be a long list because we got to put everything at the end over all 4 of those numbers. 12 is a 1, 12, 2, 6, 3, and 4. So plus minus 1, 2, 3, 4, 6, and 12. All right, now this list is going to be pretty long because we got to take all of these and put them over each one of these. So you got to do it like 4 times. Now, one thing about your list, that's why I put this one on here, is that your list should not have any repeats on it because some of the numbers come up more than once, but you shouldn't put it a whole bunch of times. So here's your list. Here we go. List plus minus. So first off, we're going to take this entire list and put it over 1. So this entire list divided by 1 will be this entire list again. So we're just going to copy down the list. 1, 2, 3, 4, 6, and 12. All right. Now what we're going to do is we're going to take this entire list and put it over 2. Now here's where some repeats are going to happen. So I'm going to do this in a different color. So first one is 1 over 2. There's not a 1 over 2 already, so we can add that to our list. 1 over 2. Okay, now we're going to do 2 over 2. So we're putting everything over this 2 right now. So 2 over 2 is going to be a 1 because 2 divided by 2 is a 1, but we already have a 1 there, so we don't have to list it again. Then we get a 3 over a 2. Then we get a 4 over a 2. So I'm on this 4, I'm putting it over this 2. 4 divided by 2 is 2, which is already on our list. 6 over 2 is a 3, which is already on our list. 12 over 2 is a 6, which is already on our list. So in actuality, we only got 2 extra values here. Okay, because everything else was divisible by 2, which was already on our list over here. Okay, so now let's add on. So we did 1. Nope, sorry, wrong one. This one. We did 1, we did 2, now we're going to put it over 5. So we're going to put a 1 over 5, which is not on our list yet. Let's do this in red. 1 over 5. Then we're going to do a 2 over 5, which is not on our list. Then we're going to do a 3 over 5, which is not on our list. Then 4 over 5. 6 over 5 is not on our list. And 12 over 5 is not on our list. So there's not really a pattern here, because as you can see, now we actually added on everything over 5 because none of these were divisible by 5, so they all had to go on our list. So 5 is done. Okay, I'm running out of room, so I'm going to start down here. So 1 over 10 is not on our list, so I'll put 1 over 10. 2 over 10, reduce it down to 1/5. So 2 over 10 is 1/5. 1/5 is already on our list, so we don't got to put that. 3 over 10, there's no 3 over 10, so 3 over 10. Now we do 4 over 10, which simplifies down to 2 over 5, which is on our list already, so don't worry about that. 6 over 10 is 3 over 5, which is already there. 12 over 10 is a 6 over 5, which is already on our list also. So that one only added up to 2. That's our entire list. Long list. A lot of them. So part of the test will be list all the possibles, and I will be looking for this list. I'm actually going to count it out and see if you got the same amount as me. I don't know where there's a comma there. But anyways, so 4/5 and 3/2. 4/5, 3/2. Turns out those two actually work. That's why I actually gave them to you, because otherwise you could sit here for a very long time before you got up to those. So let's go ahead and see what it looks like when we plug those ones in. All right, so here we go. 4/5. So I got a 4/5. And let's see here. 10, -3, -29, a 5, and a 12. So bring down your 10. 10 times 4/5. 10 divided by 5 is a 2, times 4 is an 8. 8 minus 3 is a 5. 5 divided by 5 is a 1, times 4 is a 4. 4 plus -29 is a -25. -25 divided by 5 is a -5, times 4 is a -20. -20 plus a 5 is a -15. -15 divided by 5 is a -3, times 4 is a -12, which is a 0, which is what we expected. So right here we have x minus 4/5 times, what degree did we start on? Started on x to the 4th power, so it's going to be x to the 3rd power. So 10x to the 3rd plus 5x squared minus 25x minus a 15 equals 0. Now along the way, keep trying to factor if we can. Now right here I can see that all of these have a 5 that I can actually pull out. So what I'm going to do is I'm going to pull a 5 out front, x minus 4/5, 5 out front. It's going to be a 2x cubed plus x squared minus 5x minus a 3 equals 0. Now, since that 5 is being multiplied and you're eventually trying to solve, because you're trying to find all the zeros, you can solve along the way too. So if I can pull a 5 out, I can get rid of it because it doesn't have a variable on it. It's just 5 times everything. So we're going to divide everything by 5. That's going to cancel by 5. 0 divided by 5 doesn't change anything, so we're to x minus 4/5. 2x cubed plus x squared minus 5x minus 3 equals 0. Now, another choice you could have had instead of dividing both sides by 5 is that once you pulled the 5 out of here, you actually could have distributed it into the other one because that would have made this not a fraction anymore. But, I mean, I don't see why you would want to do that because technically right now you can solve this real easily. You can just do x minus 4/5 equals 0 and get positive 4/5. So you don't have to do that. All right, so now we got a new polynomial right here. Cubic, I don't know, this is not factorable by grouping, so we can't use a pattern. So we got to go back to synthetic division. Now you can make a brand new list using the -3 and the 2. It'll be significantly shorter than our list up here because we're basically just trying to factor this one the same way we did the original. Now the thing with this though is that any list that you get out of this one, so the list that we would make out of this, say what our list was like a made of 2 numbers, then those numbers is actually going to be part of your original list too. Because if it's a 0 one part, it makes sense that it's still a 0 the other part. But I actually told you what the other 0 was, -3/2. Okay, so let's go ahead and do -3/2 because I gave you it. So -3/2. That's a 2, 1, -5, -3. So 2, that's going to be a -3, -2, -1, so 3, -2, so +3, and a 0. All right, so now what we have is x minus 4/5, x plus 3/2. We have a 2, I guess x squared, minus 2x minus 2 equals 0. We now have a quadratic. We can now start solving. So break them apart. That's 2x. So this is x equals 4/5. This is x equals -3/2. Those are 2 of our answers so far. This one, you can factor out a 2 and then divide it out. So this will just be an x squared minus x minus 1 equals 0. Not factorable. Let's go ahead and use a quadratic formula. X equals oops, let's put blank spots. B plus or minus square root of b squared minus 4 c all over 2a. All right, so my a value is so b, negative b is a -1, b squared is -1 for a, c all over 2a. Now it's just a matter of simplifying this thing down. You get a 1 plus or minus square root of 1 squared is a 1. It's going to be a +4 plus 4 all over 2. Make sure that's right. 1, -4, +4, plus 4 over 2. So this will be 1 plus or minus square root of 5 all over 2. So your 2 answers here are x equals 1 plus root 5 over 2 and x equals 1 minus root 5 over 2. Now, if you notice these weren't on our list because these are not rational numbers. Remember, it's a rational numbers or rational zeros theorem. Since these two are not rational zeros because the square root of 5 is not a rational zero, it's not part of our list. But that's basically how you do this. So let's go over this last one and then we're done. Ooh, it's a long video. But remember, this isn't due till Tuesday. So actually, you know what? On this one, don't do example 4 and then don't do the word problem that's on the worksheet. mainly because I'm going to spend an entire day on different types of word problems that fit within this type of model. So forget about this one for now. We're going to do this on Tuesday. Okay. Monday we're going to be graphing these polynomials, and then Tuesday we're going to do word problems. Wednesday and Thursday we're going to be reviewing, and then Friday will be your test on this. So do not do the last problem on the homework. Okay. Have a good weekend, and this stuff is due on Tuesday. Okay. Bye-bye.